All right, let's take a look at a little bit of a tougher example with more terms and bigger terms in adding and subtracting radicals. So I'm working with example number 1 on page 102 in your workbook. And I'm going to do part C of this one because that seems to be the toughest one. But remember, you can always watch the videos of these first ones in your enhanced Moodle book lessons. They are done in there as well. So here what I'm going to do is I'm going to take one term at a time and simplify it. So 7 will stay as it is, but root 27 can be broken down as 9 root 3. So 7 was already a whole number. Root 9 ends up becoming 3 root 3, which becomes 21 root 3. Now chances are the rest of these, big chance, but not always, that they will also be something that breaks down with a radical of 3. So root 3 times something. So I can, rather than going into a perfect square root table, I could say, let's divide 75 by 3 and see what do I end up with. Well, that gives me 25, which is a perfect square root. So that's like a tricky way of doing it. So I do get 25 root 3. And if that makes sense, great. If it doesn't, keep using the method that we're using in lesson number 1 by going through the perfect square table. So I broke down 75 into square root of 25 and 3. The negative 3 comes down as it is. 25 becomes 5. I took a root of it, and root 3 stays the same. So this becomes negative 15 root 3. Last term, again, I could try dividing it by 3 as well, and it will work out to be 49, which is beautiful because 49 is a perfect square root of 7. And then this becomes 7 root 3, and this becomes 14 root 3. So you want to check that you have the same radicand and the same index everywhere. And when you do, you take your coefficients and you combine them. So 21 minus 15 plus 14 ends up giving me 20 root 3. So you make sure you keep and check the signs for each one of them. Now let's try another tough example. So I'm going to go into example number 2, but I'm going to do part B of it because it seems to be like the toughest one because it has cube roots and it has fractions. And again, you might want to have your perfect square root table next to you because it will help you a lot. And then also, you'll notice that these numbers go up really high and fast, quickly. So you don't really need a whole lot of this table, okay? So the first one, I'm lucky. The 64 is a perfect cube root of 4. So cube of 4, so I'm going to use that. So cube root of 64 is just a 4 right away. And that reduces to 1 over 2. Tackling this one, because this ends with a 5, there's a high chance this is something that uses 125. So when you test it in your calculator, you'll find, yes, it does break down with 125 and cube root of 3. So now everything is cube root. So this gives you 2 times 5, cube root of 3, and that becomes positive 10 cube root of 3. I'm just going to bring down the half so it matches in the same line. Okay, 2 done, 2 left. Okay, 54. 54 can be divided by 27. And when you do that, I'm going to write 2 all over 23 as just 2 over 3, which is the same idea. And then root of 27 cube root of 2. So there's a different radical in this one, which is fine. This simplifies to root 3 times 3 root 2. Now, a very common mistake in fractions is when people see a fraction with a whole number, they think this 3 is going to multiply both with the numerator and denominator. Please remember every whole number is over 1. So when this does multiply, this will become 6 over 3, which then will reduce to just a 2. So the 2 over 3 times 3 over 1 becomes 6 over 3, which is just a 2 over 1 or just a 2. Okay? And that gives you cube root of 2. Now the very last one here, again, this is 5 over 2. and this is so tiny, can only be divided by 8, and that works out great because it will be cube root of 8 and then cube root of 3. And this will give you 5 over 2 times 2, cube root of 3. And then once again, this is over 1, which will become 10 over 2, which is just 5, cube root of 3. Okay? Once this happens, we're going to combine like terms. So 1/2 is a whole number or a complete number without any radicands. You can't really combine with anything. Positive 10 and the negative 5 here have the same radicands and index. So they will end up becoming positive 5 cube root 3. And then once again, this one will stay as it is because there's nothing else to combine it with. It doesn't matter in what order you write them in. You can have this term first, this second, this last, because it's addition, subtraction. It doesn't really matter. Okay? So this is the simplest you can bring it down to. I know it looks like a lot. You may want to watch this video one more time and then try it on your own.